Dear students, now we will discuss about the mathematical calculations, that how we could calculate different impedance combinations. Uh, Here example 9.10, if we want to find out the input impedance of a circuit 9.23, how we could calculate it. First of all, here is omega is given, so we have to keep on our mind that if omega is given here, so this 2 millifarad, 10 millifarad and 0.2 Henry, this should have to be converted to their similar impedances. Okay, Z1 as we know is capacitor 1 by j omega c, Z2 is series 3 ohms plus 1 by j omega c, and Z3 is another series impedance, that means 8 plus j omega L. Here is a 50 means the omega, you can see here j omega. After that, finding out the impedance, the input impedance, that is Z1 plus Z2 parallel Z3. You can see this here, see it is, look at it, Zn is Z1 and these two are parallel, these two parallel branches, and adding up to this series, and we can make up this equation. Okay, then calculate it and find out the Zin. Do this math at your home, you can easily calculate it, as I have shown you before how do you calculate these equations. After that, there is a certain mathematics, another problem. The problem is that you have to find out the V naught, and first of all, you have to find out in this solution you have to find out the impedance of this branch, and these two branches, if these two impedances are series to each other, then you can get the solution of the resistances and impedances. And for the voltage division law, you can easily find out V naught. How the voltage division principle will use here? First of all, see that this is a series circuit. So if it is a series circuit, so when you have to find out this voltage, just multiply the voltage, source voltage, to the corresponding impedance divided by the total impedance. There is the same equations are here, and easily you can now easily calculate it. How do you convert the V naught? You can easily convert the V naught by taking this Vm, that is Vm. I have shown before how to calculate from phasor to the time domain. That is the Vm cos 40. Previously in the source there is 40, and the phase plus phi is here. You will find out. And now now you can do the practice problem 9.11 find out the V naught here. Okay, the omega is given here 10. That's the omega. Okay, this is to find out the current. First you have to solve the circuit network. You have to find out the impedances. There is a parallel branch, there is a branch, there is an Y branch, there is another parallel branch. So these branches and this series all made up all the equivalent circuit analysis, equivalent resistance that we find out. Just here you have to find out the equivalent impedance. Then you can easily calculate the total impedance, and the desired current will be this, and your equivalent circuit is here. It's an equivalent circuit. Okay. Okay. And 50 degree. How do you calculate this? You can easily calculate this by doing this. 50 degree. Here 50 degree is given here. No, it's a phasor form, so it will be easy for you to calculate. From Ohm's law, V is equal to I Z, I is equal to V by Z. You can get this. And there's another math. There's your homework also. That is 9.12. Just do it at your home and find out the current. 12.728 from this circuit. I can give you a hint how to solve this math. There is a series parallel combination. First of all, you have to make this series to a single impedance. Then it will be an Y circuit. That is a delta. Okay, it's a delta block. You have to do just to solve any of the deltas, or the previous delta or the later on delta. Any of the branches. Just convert the delta to Y. Just convert the delta to Y connection. Then you can see this branch and this branch will be series, and both are parallel, and this is also series. Then you can easily calculate by dividing V. You can easily calculate I. Okay, thank you very much for being with me. I hope you will do well. Goodbye then.